Hello, sorry I'm not with you again today. I want to give you the last lecture in topic 6. This will be topic 6.4 on acid deposition. Last time we talked about how the ozone layer, which protects us from UV radiation, that's a good thing, but if it gets pushed down because of a high pressure front into the upper troposphere, it can then interact with other things in the environment there and create a secondary pollution. We call that photochemical pollution. I want to talk about another possibility for a secondary reaction here, and that is when various pollutants mix with water in the air and they create acids. So for those of you who drive cars, your tailpipe of your car puts out sulfur dioxide and nitrogen oxides. These also come from factories. They combine with water to produce acids. In this case, they combine with sulfur dioxide, we get sulfuric acid. They combine with nitrogen oxides, we get nitric acid. Both of them are very bad. And additionally, carbon dioxide, and we know there's a lot of that in the air, can also combine with water to create carbonic acid. So we have 3 different types of acids. These would be considered to be secondary pollutants. So let's just take a look at the cycle of what's going on here, either from your car or for some factory here. We have various primary pollutants being produced, for example, sulfur dioxide or nitrogen oxides. They then go up into the atmosphere. Winds tend to move them around. They combine with water up here. This fills up clouds, and clouds then can rain down, not just regular rain, but acid rain in the form of nitric acid or sulfuric acid, or I guess carbonic acid. This hits the ground, changes the acidity of the ground, also changes the acidity of lakes. And most living things can't tolerate huge changes in pH. Neutral pH would be 7. Even small changes from that pretty much can kill things. So typically people like to do IB biology experiments, see how various pHs affect germination of seeds and everything. It just kills them. It's very, very hard to do it. And this acidification then gets eaten up by, well, not eaten up, but incorporated into plants. Plants get eaten up then by animals. And this causes all sorts of changes. Also causes an increase in the amount of ammonia. And so we have a terrible cycle. Or rather, a better way to say it is that the hydrological cycle, which we studied before in a previous unit, is really being disrupted here. Okay, so what are the effects of acid rain? Well, one of them is that pH actually affects the ability of living things to absorb nutrients. And so if it gets into lakes, it affects the solubility of toxic metals, and these metals then get incorporated into fish, and fish die. So it increases the absorption into fish. The other thing it does, and really terrible thing, is that it changes the photosynthesis rate of plants, trees, and so forth. And the third thing it does is, by getting into the soil there, it changes the movement, or what we would call the leaching, of magnesium and calcium. So in other words, what's going on here, I can't remember which unit we did when we looked at various cycles, but by changing the pH of the hydrological cycle, of the phosphate cycle, of the carbon cycle, and so forth, it's changing the movement of these things and disrupting where most of the materials get in their storages. So let's just take a look quickly at an example here of how acid rain could affect soil. So soil pH should be fairly neutral, and you can see what's going on there. We get lots of nutrients in there when the pH is between 6 and 7. As it gets acidified here, 4, 5, 6, and so forth, you can see how the nutrients in soil decreases. Copper would be an exception there. It looks like boron maybe is an exception too. But a lot of the important nutrients, nitrogen would be the major one, is really being affected by the pH. Okay, surprise, surprise, there's a difference here in how acid rain is appearing in industrial, better off countries, which we call MEDC, and those which are developing, which we call LEDC. So if you look down here, where are we seeing most of the acid deposition? Well, there we go. The United States, particularly the East Coast of the United States, and Europe, and also over here in the industrial part of China. So that's where it's really getting hit. To a lesser degree, West Coast and Midwest of the United States, Southern Europe, and a little bit of Russia. Mostly acid rain is a problem, though, which is going on in MEDC. Now, there's also some natural reasons why we could have acidification. Not just pollution from your cars, but there's natural things that go on. One of them is peat bog moss. I don't know if you've ever seen this. This is very common in like northern England, Scotland, Ireland, and so forth. Peat is just an organic material, and when it gets mixed up with water, it almost makes, well, not quicksand, but it looks like a big kind of hole of oil. And if you ever fell into that, there's very little to grab onto. They used to soak sticks in it and use it as fuel because it has all that organic matter. It just lights up like torches there. But it really is changing the pH, and it leaches into the soil then. Another thing which changes the pH is simply conifer leaves. So for those of us who live up in the Northwest here, we have a lot of pine trees, conifers. Boy, once those pine needles fall on your lawn, it can really kill the grass there because it changes the acidity. You really want to rake them up as fast as possible. And the other thing which has happened naturally was volcanoes. So we already know that volcanoes pump an enormous amount of carbon dioxide into the air. That carbon dioxide would then mix with water and naturally acidify the rainwater. So what can we do about this problem? Well, the obvious thing, of course, here's your ecocentric solution, conservation. Well, let's reduce the use of fossil fuels. Here's your technocentric, right? We could switch to low sulfur. So there's a lot of factories now that put on devices, and those devices are actually called scrubbers, and they clean out the sulfur before it gets pumped up to the air. So these would be kind of your technocentric, and here's ecocentric. I suppose I could have put a anthropocentric solution in here. That would be the carbon tax. Carbon tax hasn't really caught on in the United States there. Maybe in Europe it's catching on, but that's the reason I didn't put it here. Okay, so that finishes off topic 6 for us. Hopefully you've got all the notes. And next class, I'm preparing to give the topic 6 test. So please make sure your notes are all ready for Wednesday. Thanks very much.